Everyone, welcome back. In this video, we're going to talk about a library called p5play. Now that we've covered the basics of programming, right? We've talked about creating our own variables, conditionals, loops, arrays, functions. We have all the basic building blocks. Now we're going to move into building more intricate programs. And in order to help bootstrap us into a place where we can create simple games, we're going to introduce a library called p5play. So in this week's videos, we're going to first talk about the concept. What is a library in p5.js? What does that mean? And then we'll give some basic examples of how to use p5play, introduce some of the core ideas of this library so you can start to get oriented. And then in future examples, we'll start to tackle some small games as little examples, demos around specific ideas. So what is a library in p5.js? Libraries are basically code packages that we can import that will augment what p5 already provides for us. p5 itself really is a code library. Remember, if we open the left bar here in our sketch and go look at our index file, right, we'll see that at the beginning of every web page that we built, we include two scripts. We include p5.js, right, through this cloud delivery service. And we include also the sound library, p5.sound.min.js. So p5 itself is a code library. It's basically a set of objects and functions written in JavaScript that we can use then to kind of build our own sketches and programs. So we can add on to this. Essentially, there's a bunch of libraries that have been created for p5 specifically. And the one that we're going to talk about today is p5play. So I have the tab open here already. This is the website for it, p5play.org. p5play is basically a simple game engine for p5.js. It uses a library called Box2D, which is a physics simulator, and it allows you to create sketches like this one, where you have simulated physics for your objects. It's been used, the box, not p5play, but the Box2D physics simulator that p5play uses. It's been used for all kinds of games like Angry Birds. You may have played this before, or Limbo, or Shovel Knight. So it's a great two-dimensional physics engine, and p5play just makes it very easy to get started with that engine and start to build games right away. Okay? So this is the library that we're going to be talking about in this the next few videos. Now, the way that we install libraries in p5 is we simply just add new scripts at the beginning of our index.html file. So here they're showing us how to install p5play, right? So if we want to do it offline, we can download the files, but here we're simply going to just link to these two scripts. Okay? So you want to go navigate to the p5play website, go look at this little tab here. So we already have the p5 library and p5 sound in our p5 editor. So I'm just going to select these two other scripts. So this is including a library called Plank, which is the physics engine, and then a library called p5play, which is the library we're going to learn in this video. So I'm going to copy this, go back to my editor, and go into our index.html file. And then simply just after we include the p5.js library, I'm going to go here and add these two script tags. Okay, so now I have added two more includes. I have p5 sound, and then I have these two includes. And that's how we basically bring in code libraries into our sketches. We just include additional scripts at the beginning. Okay. All right, save that. We're going to save this as well. So we're on week, let's call this p5play intro. Okay. Oh, p5play intro. All right. So now we've essentially included the p5play library in our sketch. So we can go back to our sketch. We can close this tab for now, and we can get started using p5play. Now, right off the bat, one thing that's going to be a little bit different for us is what's happening here are these underlines. Well, it doesn't matter. One thing is going to be a little bit different when we work with p5play is the way that we create the canvas. So we're going to be going back and forth here between our code and the documentation for p5play. Now, just so you get oriented, there's a few different ways this documentation is organized. It's very, very good. The way that's been done, it's got lots of very thorough examples, very detailed visual examples about all the different things you can do with the library. And it's got this kind of like mini tutorial format. So we're going to click on Get Started. So in this format here, you can see lots of illustrated examples. We're going to do our own today in this video. There's also the full documentation for p5play here at the bottom. Okay, so when you click on this, this is a slightly more sort of detailed version of the documentation that lists all the objects that you get from including p5play, and then exactly what all of these objects can do. So this is when you want to get really into the details of everything, and this is more of the didactic format for the documentation. So the first thing we're going to do is we can see here in p5play we can use this canvas object. Okay? So canvas is a new constructor we can use here that's going to build the canvas, and we'll see it comes with a few special abilities. Okay? So instead of create canvas here, we're going to simply go and say we'll say new canvas, and then just like before, we can give it dimensions. Right? This is also going to create a canvas for us like we're used to, like so. Let's say we're going to make the background black. Okay. We could use, just like before, we could use window width, window height if we wanted to. So we're going to start using the p5play canvas because down the road, it's got some nice features. For example, it'll allow us to do some kind of pixel art games if we want to. So have a small window that scales up to do pixel art. Or you can do neat tricks with it. Like, for example, you could specify an aspect ratio for your canvas. Instead of having specific dimensions, you could say, I always want a canvas that has a 1-to-1 aspect ratio. So in other words, always a square canvas. So this is going to create the biggest square canvas that can fill the window, right? So we have some space now. Or we could have a 2-to-1 ratio. So this is going to create a 2-to-1 canvas, more of a horizontal format, and it's going to leave some blank space on the page if it cannot fill the whole window. So there's other ways that we can use to create the canvas. But for today, we'll just stick to window width, window height, just like we used to do. We're just going to create a canvas that's going to fill the size of the window that we have available. Okay. All right. So now that we've made our canvas, the sort of main object that we're going to use when we are using p5play is something called a sprite. Okay. So a sprite is just basically an element in this simulated world of p5play. So it's something that exists on the screen, something that's going to move around, and something that's going to have the physics simulation applied to it. Okay? So all of the game objects in p5play are going to be sprite objects. So let's go ahead and go back to our code here, and we're going to create a new sprite. Okay. So sprites are objects, just like objects we've talked about in previous weeks. So we can put them into variables. Let's say we'll make a new sprite here. Let's put it into a variable called a ball. Okay. So right now this is a local variable, which means I will only be able to access it inside setup. Let's say we want to be able to refer to this game object we're making later on. We're going to declare this as a global variable, and we'll just say ball here equals a new sprite. Okay. Now by default, when you make a new sprite, p5play makes a few assumptions. Okay, so first of all, you'll notice it created an object in the center of the screen. So the default coordinate is in the center. It also made a box as the default with a specific dimension, and it gave the sprite a random color. So every time we hit play here, we're getting a different colored sprite. Okay, so the default shape is a box, and the default color is random, and the default location is center of the screen. You also notice something interesting happening here is that we're not doing anything in draw. Okay? So one of the things that p5play does is that as soon as you create a sprite object, there's a lot of things happening kind of behind the scenes. Once we include p5play, it's going to do a lot of the object management for us. So it knows that we made an object called sprite, and sprites know how to draw themselves, and they will automatically draw themselves regardless of what we do inside draw. In a few weeks, we'll talk about some specific game examples, and we'll see that we can change this default behavior. We can decide when exactly game objects will get drawn, But by default, just the mere fact of creating a sprite means this object now appears on the screen as if by magic. We don't have to use any drawing code. So that's pretty neat. Now our objects that we make in the game are sprite objects, right? They're JavaScript objects, so they have attributes that we can change. They have functions that we can use on them. So for example, we can set the diameter attribute of a ball, of a sprite object. Let's say we're going to set this to 80. Okay. And then by setting the diameter, all of a sudden I've changed the shape type. Okay. So if you just provide a diameter, now this shape becomes a circle, because I've set the diameter of the shape. You can see that we can change this value to make it smaller, bigger. So there's a lot of kind of clever things that the sprite object will do behind the scenes to kind of adapt itself as you set its attributes. Okay? Other attributes, excuse me, other attributes of the sprite object, sprites have a position. So there's an XY attribute, right? So if we were to give it a coordinate, we could change its location, or maybe, for example, we'll set its Y value centered, and its X value, we'll say width over 2 minus 200. We'll just put it a little bit on the left, and you'll see why in a second. So once we have these attributes that we can use on a sprite object, and if we jump back to the documentation, we'll see that sprites have a bunch of different attributes that we can affect, like a position, a size. So if we set a width and a height, then it starts to understand the shape as a box. We can also set the color, the stroke color, the rotation of an object, its diameter, and we can even include some text inside the objects. Okay, so lots of really neat things we can do with our sprite objects. For instance, we will set the balls, let's see, we'll set its fill color. Let's set the color, the fill color, we'll set it to white. Okay? So now instead of getting a default color, kind of a random color when I hit play, now this ball is going to be white. All right. Now we said our objects in P5 are going to be sprites. They have a position. They also have a speed. In P5, this is going to be called the velocity. Okay? So by default, everything is at 0, but my ball here has a velocity, and the velocity has a x and a y, just like when we had speed x and speed y. So for example, if I set the ball's velocity of x equal to 1, then my ball is going to start moving at a speed of 1 to the right. Okay? And by default, there's no friction applied, so nothing happens, right? The ball is just going to keep moving and until it stops, until it moves out of the screen. Okay? All right. Okay. So let's make some more objects. Okay. So in addition to the ball, we're going to make, let's make another object. We're going to call this one a block. Okay. So the block is going to be equal to a new sprite. Now we can set the sprite's attributes like this. Once we've created the object, we can use its properties, or we can use the constructor to kind of shortcut a few of them. So the first couple are going to be the position. So here, let's say I make a new sprite at width over 2 and height over 2. That's going to be centered in the window. And then we're going to give it a width and a height of, let's say, 40 by 40. So that's going to make a 40 by 40 cube, block, a square. So let's make a block here. All right. Now you can see what happens as well with p5play is not only we can create these game objects called sprites, these objects will now interact with each other, right? So I got my ball moving, and as soon as it ran into this block that I made, because of the physics engine, the ball bumped into the block and pushed it over. Nice. And then that also slowed down my ball a little bit. It still has some velocity, it's still moving because there's no friction applied. So these objects are just going to keep moving out forever. Okay. Now, for example, let's say we made a couple of these blocks. We're going to write a for loop here, and we're going to make 5. Okay. As soon as we make an object, it gets added to the world. Okay, so we're just going to make 5 of them. And you'll see that the simulation is going to try to prevent these blocks from overlapping, right? So if you put a bunch of objects on top of each other, I'm going to run play again. it's going to do its best to try to separate these objects out. Okay? So right now they're all started on top of each other, and then they kind of got spread out horizontally as the physics simulator tries to take these objects, move them apart. Because as per physics, right, solid objects cannot overlap with one another. If we wanted to here, let's say instead of putting them all in the exact same spot, just to make the initial layout a little bit more interesting, I'm going to add just a little touch of randomness here. So when we create them, we'll say, let's add a bit of randomness to our sprite position. We'll add a random number between -5 and 5 to both x and y. So that's going to create a layout that is a little bit more kind of scattered. Instead of being on the line, they're a little bit more scattered. Here, let's make a few more. Instead of 5, let's make 15. Okay? So we have more. And we'll see our circle moving to the right, or ball, right, bumps into these blocks and then gets slowed down as a result, and then sort of starts to like push them out, and then those blocks have now moved by themselves. All right. So to recap, right, when we work in p5play, we make sprite objects. This is going to be most of what we end up doing, is creating these sprite objects and then using our programming skills that we've learned to work with these sprite objects, get them to interact with each other, and then depending on how we program that, this is how we'll be able to build some games that the player can play. Okay, so let's add a little bit of interactivity here. So typically, you're not going to want to manipulate this velocity directly. I mean, you can here, but there's other functions that we can use to kind of create a little bit more of an interesting movement in p5play. So let's jump back to the documentation here. Let's go to this one. So just to point out here, so as you'll see, the way that the p5play documentation is structured, it's organized by topics. So we're not going to cover every single one of these. I encourage you to just explore. Every topic is very well illustrated with short code examples that kind of show you the impact of different abilities, different attributes. We'll come back to this, the physics, this idea of different collider types. We'll do a demonstration of this today. And then these examples, you can actually edit them, so you can try things out. There's like little challenges built in. So it's really good way of providing documentation. The downside is sometimes it can be a little difficult to go and find something in there the way that it's laid out for navigation. But it's not that huge, so that you can't really get lost too much in there. So I was talking about movement. So we'll see there's like different ways that we can do movement in P5 with our sprites. We can change their position directly. So you could manipulate an object's position directly, essentially causing it to teleport somewhere by just updating its XY coordinate. We'll talk about in the next video also. p5play brings its own mouse object, so a bit different from mouse X, mouse Y. We'll talk about the benefits of using that, but we'll cover that in the next video. So mouse is just one of the different ways you can handle input in P5. So you can manipulate an object's velocity directly, right? So here the objects, this is what we're doing right now with our ball. Or you can set an object's direction as an angle and then give it an overall speed, and then it will start moving in that direction. You can also apply movement like as an impulse. So here we have a key press of left that's causing the player object, which is the little circle, to move by 30 to the left, okay, an impulse. And then you can also move towards a particular object. So you can follow another object, or you can move to a particular point. Okay, so let's try that out in our program. We're going to say if we click the mouse somewhere, going back here, we're going to take our ball and we're going to move it to where where we've clicked, so we can manipulate it. Okay. So let's go and say function mouse pressed. And then we will say, in here, we will say ball dot move to, and then we will move to mouse X, mouse Y, and then the last little bit here, let's just put 1 just to see what happens. So this is moving us towards the mouse position at a speed of 1. So it's a little bit slow. So we're going to move this up to maybe like 8. All right. So now if I click somewhere, my object is going to move at a constant speed right towards that point. Okay? So we could use mouse X, mouse Y like we normally would do in p5.js. As you saw briefly in the documentation, p5play also has its own mouse object. So the mouse object is mouse.x and mouse.y. Okay? So currently these two are the same, and we'll talk about some of the different things we can do with the mouse object in the next video. Okay? So we could just use mouse X, mouse Y for now. These are going to be equivalent. So now I can click behind this little wall here and kind of make my way through this bunch of blocks. All right. So let's add one more thing to our little test scene here. And in fact, I'm going to go and get rid of this line here where we start our ball off with a velocity in the beginning. We'll just get rid of that so that we start not moving, and then if I want to move, I have to maybe click on the other side, and then my ball is going to try to get through that little cluster of blocks. Okay, so let's make one more object. We're going to make a wall. Okay? So our wall is going to be just like the others. It's going to be a sprite. Okay, so let's position our wall on the right side of the window. So we're going to set its X location to width, its Y location to height over 2. So by default, all the p5play object, right, its location is always going to be in their center. So we'll position our wall like right over here, and we're going to give it a width of, let's say, 20 and a height of height so that it fills the entire window. So let's see what that looks like. Okay, so now we have a wall, and we're going to move our circle. Now, if other objects bump into the wall, right, currently the wall behaves exactly the same. We get a random color for it too. Let's give it a fill color of white, just like the ball, so that we can always see it. Okay, there's the wall. So currently, if we don't say anything else, by default, all the objects in the world of P5, right, have this this quality called dynamic objects, which means they can collide with other objects, and they all kind of get to interact with each other in this little simulated world of physics. So as soon as some of these boxes hit the wall, they're going to start to push the wall away. Okay? This is called the collider, what we're about to set, and there's a few different options for colliders. So the default is a dynamic collider, and here what we're going to do is after we create the wall, we're going to set the attribute called collider, and we'll say this attribute actually should be static. So a static collider just means that we'll have an object in our scene now, which is going to be there. Other objects will interact with it, but that object is now fixed. Okay, it's static, which means it cannot be pushed, and it's not going to be pushed around by other objects in the scene. Okay, and if I get my ball to try to get through it, it's going to bounce off. Right? So my ball is now bouncing off the wall. If I try to click through, okay, it's not going to be able to get through. So static objects are useful if you want to build floors, walls, maybe platforms, things that your game objects are not going to be able to get through, but that other objects in the world are going to still be able to interact with. So that's we have dynamic, we have static colliders, and then the final type that we have is something called a kinematic collider. So we'll just do a quick demonstration of that right now. So currently my ball has the default collider, and we'll just write it here, collider, right? The default is called dynamic. So if you don't say anything when you create a sprite, it's going to assume dynamic. So what that means is that this object interacts with the other objects and vice versa. So the blocks are having an impact on my ball. So you can see that as it bumps into them, my ball kind of stops a little bit because it just bumped into something. There's some resistance. The final type that we have is something called kinematic. So a kinematic object in P5 is going to interact with others in the scene, but the reverse is not going to be true. So the kinematic object is not going to get impacted by other objects in the world. So you'll see the difference here. If I click on the other side of the blocks, right? Now this circle is just making its way through, right? Let's run the simulation again. It's making its way through, but the blocks no longer have an impact on the circle, right? So it's more like a one-way calculation now. So a kinematic object might be useful if maybe you have like a spaceship that's shooting some lasers or something. The lasers should be kinematic objects. You want them to impact other things in the scene, but not get impacted by other objects. And then you see what happens with my static object. My kinematic object is basically going right through it. Okay, so it's not, they're not really impacted by one another. So 3 different types of kind of object types we can have: sprite types. We can have dynamic ones that are just, they basically exist in the world and they're fully simulated, fully impacted by the physics. We have kinematics, which allows you to push other objects around, but they themselves cannot be impacted. Right? So for example, if I move these and then, well, it's a little bit tricky to do, but yeah, you can see that they cannot be impacted by the squares that they're pushing around. Okay? And then finally, we have static objects. These are just fixed static objects. They don't move, and they're useful for creating things like walls, floors. They will block other dynamic objects. So let's get our collider to stay kinematic here. Okay, cool. All right. Very cool. Okay. Now, really quickly, just for fun, I also want to show you that we can create sprites at any time during the program, not just during setup, right? So now in setup here, we're making our ball object, we're creating a sprite, then we're setting its attributes. Here I have a for loop. Oops, I accidentally closed it. Creating a bunch of new sprite objects I'm putting into these block variables, and I have my wall. Okay? So at any time, we can always just add more sprite objects into the world. For example, let's take this idea here where we have a little for loop creating a bunch of sprites. We're going to write a quick function here. Let's call it make blocks. Okay. And then we'll put that code in here. So we're going to get rid of that code over there. So we'll put the code in here, and then we'll put maybe a parameter to the function. Let's call it n, and that's going to determine how many times the loop repeats. So when we call make blocks, we'll be able to put a number in, and that's going to create n number of blocks. Okay. So for instance, in setup, now we could say make blocks 15. Okay, that's what we had before. Make 15 blocks. Okay. But now we could also create more blocks later on. We could say, let's put in a mouse key pressed, just for a little change here. And in key pressed, we'll say make blocks 5. Okay. So now we could go here, start our program, and then if we wanted to get more blocks again, I could press my keyboard, and now every time I press a key, it's making more blocks. Okay, and then I can send my kinematic object right through. Just to play around with it. Okay. So anytime we can call new sprite, and that's simply going to go and add a new game object into the world, whether it's in setup, whether it's later on, right, at different times. And P5 is keeping track of all these objects into one big giant master list called all sprites. We don't see it. All sprites is an array. Eventually we'll explore different strategies to keep track of objects. So right now we have our ball variable. What if we have multiples? We could put them into arrays, but we'll see in future videos, P5 also has this concept called a group, which is going to use to organize sprites into these logical groups. We'll explore that in the next video. But we can create more sprites at any time. And one thing worth noting at this stage is that, you might be worried if you're just making more sprites, right, all the time and then just pushing them off screen. P5 has an automatic way of handling these objects that are going off screen. So whenever an object gets too far away off screen, I think it's something like minus 10,000 X or minus 10,000 Y, or just far away off screen, these objects will automatically get deleted. So you don't have to worry about having too many objects no longer visible, kind of like slowing down your game. If objects are no longer useful, if they've flown off screen, they get automatically taken care of. We'll see in the future, we can also decide when we want to delete objects. So we'll have that option as well. We can have some control over when objects get deleted. Okay. The last thing we're going to do in this example before we move on to a few other demos for this week is we're going to talk about collisions. So another really key concept of working with p5play is going to be this idea that our objects can have collisions, which is when a sprite runs into another sprite, and the physics engines is going to detect this, right? So if I bump into one of the blocks with my ball, every time two objects touch each other, this is called a collision. And we can respond to collisions using events. So for example, we could say every time we make a new block, okay, we're going to tell the block, okay, we're going to say collides. So every sprite object has a collides function inside of it, where we can ask the sprite if it's colliding with another specific game object. So here we're going to check if the block is colliding with the ball. Okay, we'll say block collides ball, and then we're going to put in a function here as that's going to be called a callback function. Okay? So this function is going to be essentially a custom event we get to create. So let's call this collision. Okay, so this doesn't exist yet, so we're going to have to define it. So we're going to create a function called collision, and the parameters to that function are going to be the object, right, that's colliding with this other object. So this is going to be ball and block. Oh, actually, no, the first one is going to be block and then ball, because we called the collision function on the block sprite, and we said if the block collides with the ball. We could have done the other way around. We could have said ball.collides block, okay, and that would be the same thing. It just will affect in which order do these two attributes get, these two variables will get passed to our function. Okay. So now we've made our collision event, and what we can do at this stage is we can basically respond. So this code will run whenever the block is hit by the ball. Okay. And we can say we'll be able to see which block. It will be this variable here, and then this is the specific, this is a reference to our ball variable. So for instance, we could just simply here, just to demonstrate, we're going to say block.fill is going to be equal to white, okay, just to see that something happens. So by default, right, our sprite objects, they just get a random color if we don't specify. Now, every time they collide with the ball, the color is going to transfer and they're going to become white. So that's the other really, really powerful thing that we get with p5play. In addition to the cool physics simulation and animation, is we'll have the ability to detect when two sprites or two game objects touch each other or overlap with each other. And we'll be able to use that to create all sorts of really interesting game mechanics. All right, one more time. And also we can add more objects. And now as soon as my ball touches one of these objects, right, we get that collision code that runs. Okay. Okay. All right, so we're going to leave it at that for this first example. We're going to do 2 more examples this week just to talk about other areas of p5play, kind of fundamental concepts of p5play. And then in subsequent weeks, we will go into more of actual game examples, short games. Okay? So I'll see you in the next one.